In this video, we're going to be going over the 3 worst answered GCSE Chemistry Paper 1 questions. Make sure to stay tuned if you want to see the question. That is a 4-mark question that only 1/6 of the students that sat this paper got just even 1 mark for, so a very good question to keep in mind for your future exams. And this is from the 2022 paper. And always remember that GCSE papers and questions can be very similar from previous years, so it's vital that you watch this video until the end, as there's a good chance something similar could come up in your exam. And this is a second of a series of these videos, and we also post other study related content and study tips, so subscribe now to ensure that you don't miss out on this, and after this make sure to check out our previous one that we did on the biology paper. Now to the first question that's very poorly answered on this paper, and the examiner's report just says that a few students gained this mark. The question asks, why is excess zinc oxide used rather than excess hydrochloric acid? Now feel free to pause the video here and practice having a go at this yourself. And the examiner's report says about this that many students said the reason was to use up all the acid without considering why that was necessary. And it also says that students seem very familiar with the method for making a salt, but they appear less familiar with the reasons for each step. So make sure to get a pen and paper or save this video, as I'm going to tell you the exact sentence that you should say for this question if it comes up again. And this short sentence is that excess zinc oxide can be filtered off. So just to explain why this is the answer, the reason that you want to in the first place add an excess is to make sure that all of the acid is reacted. And then the filtering removes the unreacted insoluble reactant from the salt solution. And as all the acid is used up and the insoluble reactant has been removed now, this only leaves the salt and water. And therefore, when you do the step of evaporating the water, this leaves the pure salt on its own, which is the desired outcome for this experiment. Now, moving on to the next question, and this is a question that is described by the examiner's report as a high demand calculation, and students found it difficult to analyze the correct approach to take. So let's go through this question, and this question is 7.6. So it shows us the equation for the reaction, and it tells us that 30 centimeters cubed of Si2H6 is reacted with 150 centimeters cubed of an excess of oxygen. Calculate the volume of gases present after the reaction. All volumes of gases are measured at the same temperature and pressure, and this is for 4 marks, so this is a very important question on the paper if you want to get a good grade. So the first thing that I want you to do for this question is calculate the volume of oxygen for 30 centimeters cubed of Si2H6. And for this, we're going to do 3.5 times 30. Now, you may be wondering, why 3.5? Where have I got this number from? And I want you to go back to the equation, and I want you to look at the number in front of the Si2H6 and the number in front of the O2. And this is the molar ratio. So we can see it's 2 to 7. So if we want to get from the 2 to the 7 so that we can calculate the level of oxygen, we want to times by 3.5. And for this, we get 105 centimeters cubed. And the question has already told us that we have 150 centimeters cubed of an excess of oxygen. So what we're going to want to do is we want to calculate the volume of excess oxygen. So we're going to take what the question has already given us, and this is that there's 150 centimeters cubed of an excess of oxygen, and combine this with our previous calculation. So the total volume of excess oxygen is 150 take away 105, and this gives us 45 centimeters cubed. For the third mark, what we are going to do is we're going to calculate the volume of water vapor. So we're going to take the volume of the Si2H6 and we're going to times this by 3, and we're going to be left with 90 centimeters cubed. And now it's time for the fourth and final mark, and the question does ask to calculate the total volume of gases present after the reaction. So what we're going to do is we're going to take the volume of the water vapor, which is 90 centimeters cubed, and add it to the volume of the excess oxygen, which is 45 centimeters cubed, and our final answer is going to be 135 centimeters cubed. So give yourself a big tick if you got that correct. Now there is an alternative way of working this question out, so I'm just going to leave that on the screen now, and feel free to pause or save this video if you prefer this method, but I think just the method that I went through is probably the simplest for the overall number of students that are watching this video. And I am aware that this is a very, very tough question, and many students still may not understand after going through this question. What I would say about this is that please go over the theory for this question, because if you don't understand how we got each step of this question, this may just be because you haven't recently revised this topic, or you don't completely understand how to calculate these volumes of gases, for example, or how excess works. So what I would like you to do, if you're unsure about an aspect of this question, please write it in the comments, and either myself or someone else in the comment section will go and answer your question and explain exactly that point. Now, time for the third and final question that we're going to be going over, and this is question 8.5, which is again poorly answered in the exam. And this question, for a bit of context, is talking about a titration experiment involving sulfuric acid and barium hydroxide solution. So for question 8.5, it states that the student added a further 10 centimeters cubed of barium hydroxide solution. The electrical conductivity of the mixture increased, and give one reason why. And this is the final question on the paper, so you can imagine it's quite a difficult one, although it's only 1 mark. And the exact answer that you should put for this question is that the mixture now contains barium ions and hydroxide ions that are free to move. That's all you need to get for this question. The mark scheme does also allow you to say that excess barium hydroxide solution contains iron, so you would have gotten away with the mark as well if you had just stated like that, or rephrased a few words here and there slightly. My biggest advice for answering questions like this, or just studying in general, is to make sure that you go through mark schemes of past paper questions, because questions do repeat and therefore mark schemes do repeat. Even though that revision guides might vary or your teacher explanations may vary, the mark scheme is generally what stays quite consistent, and word for word is kind of showing you what you need to write down. So I think it's a lot easier to study from as well. Now in the comment section, I want you to test each other's knowledge. So I want you all to write down one GCSE chemistry question and allow someone else who has watched this video to answer this question, or you can send it to a friend to answer this question. So I'm going to start off. So head to the comment section below if you want to see the question that I've posed to you, and let's see who can be the first person to get this correct. And as usual, the link is in our video description if you want to book a free one-to-one taster lesson with one of our tutors, and I'll catch you on the next video. Thanks for watching.